Hello everybody, welcome back to my YouTube channel. This is Hemishri. So today in this video I'll be talking about the topic classification of electrical networks, which comes under the subject network analysis. So let's begin with the video. So now let's begin with the introduction. What are electrical networks? An electrical network is an interconnection of electrical components like resistors, capacitors, inductors, and power sources. These components are connected in a way to allow current to flow or manage signals. Examples: electric circuits, power grids, signal transmission systems. Then we have the importance of classifying networks. So it simplifies the analysis, that is, helps in understanding and analyzing the behavior of circuits. And the other importance is optimized design. It enables engineers to choose the right type of network for specific applications. Adding to it, effective troubleshooting, that means it makes it easier to identify and resolve issues. And foundation for advanced studies provides a base for designing complex electrical systems. Moving on, for the classifications based on components. So we have two types of networks for the classifications based on components, that is active networks and passive networks. So active networks are that contain at least one active component such as voltage or current sources. Example: batteries, transistors, operational amplifiers. Then the characteristics of these active networks are: it can supply energy to the circuit and also capable of amplifying signals. Examples for this are amplifier circuits and oscillator circuits. The second type is passive networks. So this is a network that consists only of passive components like resistors, capacitors, and inductors. So the characteristics of these passive networks are: it cannot generate energy and dissipates, stores, or transfers the energy. Examples for this are RC filter circuits, RL circuits for signal filtering. Moving on, for the classification based on linear properties. So there are two types again in this, that is linear networks and non-linear networks. For linear networks, these are the networks in which the parameters, that is resistance, inductance, capacitance, remain constant irrespective of the applied voltage or current. The characteristics are: follows the principles of superposition and homogeneity. The output is directly proportional to input. Examples are resistive circuits with constant resistors and RLC circuits with small signal operation. Then the second type is nonlinear networks. The definition is networks in which the parameters change with variations in voltage or current. The characteristics are: it does not follow superposition or homogeneity. The output is not proportional to input. Behavior is non-linear. So examples for nonlinear networks are circuits with diodes, transistors, or saturable inductors, and power electronic circuits. So now coming to the other type of classification, that is based on time variability. So here the first one is time variant networks. So these are the networks whose parameters such as resistance, capacitance, and inductance do not change with time. And the characteristics of these time variant networks are: it behaves its behavior is, that is, it remains constant over time, and it is easier to analyze due to steady parameters. So examples are a resistor capacitor circuit with fixed component values, power distribution networks with constant load. Then we have the second type, that is time variant networks. So these networks whose parameters change with time, so the behavior varies over time, making analysis more complex and often used in systems with adaptive or dynamic properties. So examples are circuits with variable resistors, that is a rheostat, switching circuits in a communication system. Our next type of classification is based on direction of current flow. So the first one is unilateral networks. These are the networks that allow current to flow in only one direction, and their characteristics are: It is non-reversible in behavior and typically include non-linear components. And their practical applications are they are used in rectifiers, power supplies, and one-way signal flow systems. Then the second type is bilateral networks. So these networks that allow current to flow in both directions, and the characteristics are reversible in behavior and typically consist of linear components. So the practical applications of these bilateral networks are they are used in transmission lines and in passive networks like resistive or inductive circuits. Now let us know about the significance of network classification. It simplifies design and analysis. Classification helps in choosing the right type of network for a given application, ensuring better performance and reliability. And it optimizes performance by understanding the characteristics of different network types. One can optimize systems for efficiency, stability, and cost effectiveness. The other thing is it facilitates problem solving. It aids in diagnosing and troubleshooting circuit problems by recognizing the type of network in is used. And the last one is foundation for advanced technologies. Network classification is foundation in the design of complex systems such as communication networks, power grids, and electronic devices. The final thought of this is understanding the classification of electrical networks is crucial for anyone working with electrical and electronic systems, as it lays the groundwork for designing and analyzing circuits and systems that are both effective and efficient. So thank you for watching the video. Hope you guys understood. Please do like, share, and subscribe. Thank you.